These are unprecedented times. From emerging to spreading to being considered a pandemic, COVID-19 is something really special. This disease is caused by a particular virus, part of the coronavirus family. Some cause common colds, but the others are trouble. All viruses exist for one purpose: to make copies of themselves, using our cells. Cells are like parties. There's a host that gives an agenda to a party planner who entertains other guests. Doormen let invited guests in, and there's security. Sometimes unwanted guests crash the party and hijack the agenda. By hijacking the agenda, they turn other guests into viruses and spread to neighboring cells. But every virus is unique. Each has its own special doorman, their passkey to entering, and their own agenda to hijack our cells. Take influenza, the virus behind the seasonal flu. Because its agenda is RNA negative, after entering, it must go to the nucleus first. The coronavirus family all have RNA positive agendas, allowing them to go directly to the ribosome to start replicating. Sorry, Flu, but coronaviruses have an advantage. The agenda, aka genome, is what makes them viruses and dictates how they look and behave. When comparing the coronaviruses, we see differences in certain locations related to structure and function, which is what allowed COVID-19 to become a pandemic. SARS-CoV spread between humans mostly once severely ill, making contact tracing easier. Now, SARS-CoV-2 can spread without showing any symptoms. But, just like security, our immune system takes action once infected. When viruses hijack the party, the ensuing struggle is like a game. There are offensive interferons that stop the virus from replicating, defensive backup outside, and signal chemokines who call the backup. Scientists are finding SARS-CoV-2 to be really special, weakening the interferons and promoting chemokines to call too much generic backup, leading to pneumonia. But luckily, science is humanity's superpower. Scientists are working on treatments ranging from stopping viral replication within the cell to blocking SARS-CoV-2 from using receptors in the first place. Others are working on vaccines that give our immune systems a sneak peek at how SARS-CoV-2 plays. Some are also studying transferring players from recovered patients to coach immune teams of other people. Since mathematically, spread depends on how many are infected, exposed, and the likelihood of an exposure becoming an infection, we can all help. Social distancing reduces exposure, and good hygiene reduces the likelihood. We have faced epidemics and pandemics throughout history, learning many valuable lessons, and I know our global community will emerge from COVID-19 better than ever before. Thanks for watching.